Hi Geo 108. My name is Jared Lovell, and for my paleoclimate proxy I have chosen Loess Formations, and I want to take a little bit of time to explain to you, what Loess Formations are, how they formed, and how they're used to explain past climate conditions. So what is a loess? A loess is an Aeolian silt sediment that have been deposited and accumulated during times of reduced precipitation. And so there is a German gentleman named Carl Cäsar von Leonhard in the 1930s that traveled between his home in Germany and Mississippi, and he noticed that there was a lot of similarities between these two formations that had that were forming there, and they were so similar that he figured they must have been created by similar processes, and so he chose the term loess is derived from the German word for loose to kind of describe the texture of these formations. And so loesses are very, very widespread. Some of them are very, very large, and they cover about 10% of all the landmass on Earth. They produce some very, very fertile soils. They grow. Crops grow very, very well in soils that are generated from loesses. And we're going to focus on two different kinds of loesses, both periglacial loesses, which are formed primarily from weathered material from glaciers, and there's also non-glacier loesses that form primarily on the boundaries of deserts. So the reason that loesses are such good records of past climate is that they have layers. They have layers of loess, and so loess can refer to both the whole formation in its entirety, and then also refer to just the material. So there's loess formations and loess material. So it can have layers of loess, and then layers of what's called paleosol. And paleosol paleo meaning old, and sol meaning soil. So it has layers of loess material and paleosol. And so loess material, it's very light in color. It's not weathered very much at all. Whereas these paleosols, you can see they're much darker. They're previous soils, and they show a lot of chemical weathering in them. And so I would encourage you to go ahead and pause the video and maybe think about why might we have these layers, so these alternating layers between loess material and paleosols. This slide gives you a really good hint as to why that is. We're going to see lots more Aeolian transport, or we're going to see a lot more weathered material being transported when it's cold and dry, and we're going to see a lot more paleosol formation during when it's warm and wet. And so when insolation is low, so when we're having much less direct sunlight striking the earth, global temperatures are going to start to drop. We'll see glacial formation, and we're also going to have a less strong monsoon effect. So it's going to get colder and drier during periods of glaciation, and it's going to be warmer and wetter when the glaciers, when insulation is strong and the glaciers are starting to melt, and so these alternating layers of loess material and paleosols are really very, very strong records of the strengths and the regularity of monsoons. Well, it had long been understood that Loess formations showed the strength and regularity of monsoons. It was another matter to prove it. Dating of terrestrial sediments is very imprecise, and so showing that a particular sediment is either 200,000 years old or 250,000 years old is very, very difficult. And so what they decided to try is see if they can compare these Loess formations with other more accurate climate proxies. And so what they did is they took a sediment core from very far out in the ocean, very, very far away from any sort of rivers that might contain sediment, and they decided to look at how much mineral content was in it. And any on the ocean floor is it has this constant rain of organic sediment, and there's there's no other source of mineral besides some volcanoes perhaps, but very, very little other mineral content gets to the ocean floor. And so they were able to compare these oceanic sediment cores, and what they found is that they correlate very, very well with the Loess formations. You can see here during times of Loess creation, Loess deposition, we have very high flux, so a lot of sediments are going into the ocean, and then we also have a very high oxygen 18 concentration in the oceans. And you can remember that high oxygen 18 concentration indicate that there's a lot of ice formation, a lot of permanent ice formation. And then you can also see down here during Paleosol formation we have much lower flux, and we also have a much lower concentration of oxygen 18, which indicates that there's less ice. So we can say, and it repeats itself, during times of Loess deposition, we have high flux, high concentrations of oxygen 18, and it keeps alternating. And one other thing that I'd want to point out is that we have every 100,000 years, it looks like there's a pattern. And so why don't you go ahead and pause the video and think, well, what sorts of what does that indicate? What sort of processes involved with this regular 100,000 year interval again and again and again. Okay, so far we've just been talking about Loess formations in general, and I want to talk a little bit more about glacial Loesses, or Loesses that were formed primarily from glacial material. And so you can just imagine that a glacier is not it moves. It's not immobile. It's slowly grinding and crushing the rock underneath it as it moves, and so it's creating it's a very, very strong weathering agent. It creates a lot of very fine material as it moves. But if it doesn't melt, then that sediment really doesn't have an opportunity to go anywhere. But as the glacier retreats, as it starts to melt, it creates a lot of liquid water, and liquid water is a very strong erosion agent. So it's going to take a lot of those sediments that were in and underneath the glacier, and it's going to wash out. And so as these massive continent-sized glaciers are retreating, they are leaving behind a lot of very fine and very loose material. And so, while global temperatures, on average, would still be increasing, you'd still have seasons. You'd still have summer when there'd be a lot of strong, strong sunlight, and your glaciers would start to melt. But you'd still have winter, and the melting of the glacier would be reduced. You would have less runoff from the glaciers, and all of these sediments that were being transported by the water would just be deposited in these plains. And so the water would dry up, and then wind would come and pick up these loose material and deposit it somewhere else. And so when I think it's fairly intuitive that heavier, larger pieces of weathered material aren't going to go very far. So gust of wind will come up, and it'll just move it along just a little bit. Something that's a little bit smaller, a gust of wind would come along and it would pick it up, but then it would fall back down again. But the really fine material would stay suspended for even longer, and it would can get transported for quite some ways. And so in the Loess formations, the size of the material can be an indication of where the material came from. We can show, we have other methods of showing where the glaciers were, but this is another method that we can use to show, how, where were these plains, where were these floodplains in front of the glaciers. One of the interesting things you can do with Loess formations is you can look at the relative mineral content in all of their layers, and you can extract some information about what the conditions were like in that place at that time. And so you can look at the concentrations of a mineral that withers very, very quickly, like say sodium oxide, to the concentration of a mineral that weathers very, very slowly, like titanium oxide, and you can that will show you how the rate of weathering, what the rate of weathering was like at that time. And so there was a gentleman, Dr. Muse, went to Alaska, and he was able to look at this exact thing in some Loess formations, and he was able to determine that the rate of weathering in the Paleosols, in the interglacial periods, was very, very similar to what we're experiencing today. And so the conditions in the soils at that time were very similar to modern conditions. So it backs up. We had a good idea of what the climate was like, but this is another way to show that. So it reinforces something that we already knew, but also it's something that gives you really high resolution. It's these Loesses existed in that place, or very close to that place at that time. So these minerals were exposed to the elements, and you can gather a lot of information that way. Artemis was able to take that one piece of information about the weathering and combine it with other climate proxies like the fossil record and the pollen record, and make some reasonable assumptions about what sorts of plants existed at that time. And so Alaska is it's still pretty cold, even though today we're not in a glacial period. It gets pretty darn cold up there, and you really wouldn't, based on the temperature, you wouldn't expect a lot of chemical weathering. But there are some very local conditions that can enhance chemical weathering. Like if you have a lot of tree cover, it shades the ground, it will reduce the evaporation, so your soil will be more moist for longer. If you're in a dense forest, it can have some really thick soil that has a lot of activity in it, and the creatures that live there and the plants that live there create chemicals that enhance the weathering as well. So even though it's cold, you can still have a really local enhancement of the weathering of these soils. And so when you combine all of those pieces of information, you can say, well, here, right here where this Loess structure was, we can say, yeah, this wasn't like a prairie, it wasn't tundra, right here, this is very likely a dense forest that existed right here in the past. And so I think that's kind of neat. You can make, when you combine all of these really well supported climate models together, you can get some really detailed you can make some really detailed assumptions and really reasonable assumptions about what was going on long before people existed. And so I hope you enjoyed my presentation, and I look forward to seeing all of yours. You have a good night. Bye-bye.